guys, Cam back here at the Battler Workshop and welcome. We've had a bit of an issue with the Victor Lathe. I was doing some machining on timber to make up a mandrel to machine some acrylic shoe, and the day was quite hot actually. It was 36 degrees here in the workshop, and I was about to pack it in. I was going to do that one last machining job on that mandrel and finish up for the day because it was getting very warm. Went to start the lathe for the final time, and there was an almighty bang, and I mean bang. It was like a shotgun going off. It was very loud. There were flames and smoke emanating from the back of the Victor lathe. All the power went out in the shop and went around the back. The drive was on fire, and there's been some sort of a catastrophic event occurred inside that drive. So I got the flames out, and I've taken the drive out and stripped it down to have a look and see what that motor failure was in that drive. So I've got that in pieces up on the veranda, so we'll pop out and have a look at that and see what's gone wrong with it, and we'll have a talk about what we're going to do to get the Victor lathe up and going again. And there's quite a few things that need to happen for that, and I'm part way through that solution now. So let's go to the veranda, have a quick look at what happened to the drive, and then we'll come back inside and see what we're doing about it. Alright, so as I said, I've stripped this down to have a look at it. That's the front terminal plate. No issues with that board. However, this board has got some issues. Two very large resistors here. Obviously there's an awful lot of power going through here to trick this up from single phase 240 volt up to 3-phase 415 volt. There's a lot of heat and energy involved in doing that, and a lot of that, I'm assuming, will run through these two resistors. So you can see this resistor here, it's had a great chunk blown out the side of it. That's caused the plastic on these two high voltage relays to catch fire, and that's spread up through it. Looking at the second resistor that's there, you can see there's been an awful lot of heat generated from that one too. I don't know if you can pick that up, but that's also started melting the plastic terminal block at the back end there, and that wasn't far off going either. So a little bit of a mess, and obviously that's dead. It's not going to be running anymore. As I said, it was 36 degrees in the shed at the time this happened, and you might recall I did a fiddle on this to get some controls over the fan noise, and I put in some bimetallic switches in the back here. These are set at 5 degrees apart. I think one's set at 45, one's set at 50. So when the issue occurred, there was one fan running at the time. I very rarely had the two fans running, so I had the one fan running most of the day. So whether that's been an issue, me putting some resistance into these fans so that they only come at a set temperature, or whether it's just an issue with the design of the drive with the amount of heat that's being generated, not too sure. But anyway, it's dead now anyway. Alright, so there's no recovering from this one. So what we'll do is we'll go inside, back into the workshop, and I'll have a look at, show you where we're part way through the solution for getting the Victor lathe back up and going again. Alright, so I guess the solution is I've purchased a new motor. This is a straight 1440 RPM 5.5 kilowatt 4-pole motor. This was the existing motor. This is a 2-speed motor. It's both an 8-pole and a 4-pole. I was running that off the 8-pole taps as 415 volt 3-phase. And I've purchased a new drive. This is one of the Follon units. I've got one of these currently running on my high power lathe. I had the Highwind units on there, but I've had two of those go out, destroy themselves, and I've had no issues on the lathe since I bought the other Follon unit, so I've purchased another one of these. So I've got this fully wired in now, and I've got the control onto the lathe. So when I hook these things up, I usually do the programming offline, so I just hook in the single phase. do all the programming, get that all set up, and these particular ones, there are something like 150 parameters. You don't need to modify all the parameters, you just need to know which ones you need to modify for what you're going to be doing. So I do the offline programming. Once I've got that done, I'll then wire in the motor and run that off the keypad. Once I've got that running and I'm happy and satisfied, I'll then hook in the controls from the motor relays and I'll wire them into the inverter, and then I'll bring the controls back on over to the lathe, which is what I've done. However, I did have a little issue trying to get this to work. I couldn't get the lathe controls to work. I could override the relays manually and get the motor to run, but I couldn't get it to run through the motor. Through the lathe controls. So I had to do a fair bit of tracking down, and I'll show you what occurred and what held those functions out. Right, guys. So this is at the foot of the lathe. This is where the motor mounts. Now, to get the motor out, I had to raise the base up so I can get the belts off and then get the motor out. And in doing so, I've tripped the little micro switch for the foot brake on the lathe, and that micro switch was holding it out, stopping me from using the lathe controls, which is what it's designed to do. But it was only after an hour and a half of going through the programming again, going through my wiring setup again out of the relays into the inverter control, that I clicked that maybe something's holding it out, and this was the thing that was holding it out. So once we'd sorted that out, up she came. She ran beautifully, so we've got the motor running. All right, we'll just quickly set you up and just show you that running, and then we're going to show you what we're going to be doing next on this job to get this lathe back in action. All right, we've got the power on the lathe. Let's fire it up. So I'm running it forward there, and we're running in reverse there. I'm only got that running at about 12 hertz. So fairly slow. I've also got this drive set up as a 5-second acceleration, so it's quite slow at the moment, just while I'm playing around with it, but we'll get that set up. You might notice that everything's live here at the moment. I've got nobody else here in the workshop, and everybody else in the house knows not to come out while I'm fiddling with this stuff, but very happy with how that's going. Alright, let's have a look at what we're going to be doing with this motor to get it to fit. I might note too that when I've got this motor offline, I do kill both the main isolator and the breaker as well, just to make sure, or doubly make sure there's no power going through to this thing. Alright, so this is a 5.5 kilowatt or 7.5 horsepower motor. It's a 132S frame. The one that's come out of the base is a 132M frame. Now they are identical in most ways, except the center distance between the mounting holes. The M frame is about 30 millimeters longer. So I'm going to have to take the base plate out and do a re-drill to suit that. The other issue I've got is the shaft. This shaft is a 38 mil diameter, whereas the one that's on the old motor is a 32 mil diameter. So you can see here the pulley and brake drum assembly. Now I could machine this out. It would make the wall fairly thick. I might have to put in a support ring around that to give it a little bit more meat, but I'm going to make a new one of these. This was very, very hard to get off, by the way, too. Took a lot of work. So I have designed this up. It's going to be a 2-part unit. So the brake drum for the band brake, for the foot brake, is going to be a separate item, and the pulley assembly is going to be a separate item. So I'll machine those as a close tolerance fit to put the two together, and then we'll just put a bolt pattern around here to secure the two together. Obviously it's going to have the 38 mil bore in it, and then I've got to cut a keyway into that as well. So we might use that using the slaughter off the Bridgeport head. We'll have to do them as two separate jobs. I haven't got the stroke to get right through that, but I think I'll be okay with the stroke, just with the pulley on its own and the brake drum on its own. So I'm going to get the base plate out first. There's probably no point filming all that. It's going to be fairly awkward and tricky, and then I'll re-drill the mounting holes for it. Looking at the base, it actually looks like it was designed to suit either the 132S or 132M frame. The machine pad on this is quite large compared to the front. The distance from the front hole to the end of the shaft is identical on both motors. The distance between widthways, the holes, is identical. As I said, the only difference is the centre distance in the lengthway direction. So this new hole is going to go about here. Alright, when we get on to that, when we've got that sorted out, we'll come back and look at what we're going to do with this pulley, and we'll do a quick filming of the making of that pulley. That'll be in another part. Alright guys, well, we're into it. I might just mention the cost too. So for me to get this new motor and this new drive was $1,300, so it wasn't a cheap purchase, and it certainly hurt a little bit, but I do want to get this lathe up and going again. That inverter drive, the 415 volt, has been on the lathe for about 4 years now, and 3 or 4 years, and it has copped a lot of use. But obviously there's been some issues with overheating in those resistor banks. Alright guys, we'll get into this job, get it on the go, and we'll catch up with you soon. Cheers for now.